Balancing chemical equations. In this video, I'm going to teach you a very systematic way of balancing chemical equations, which can help you to balance any chemical equations, no matter how complicated equations are. Okay, before we start, let's recall a few important facts about chemical equations. Atoms are not created or destroyed during a chemical reaction. Hence, atoms are only rearranged to form new products. Hence, the total number of atoms of each element must be the same before or after a chemical reaction. Before you start to balance an equation, make sure that all formulae of all reactants and products are correct first. And when you are balancing equation, you only add numbers at the front of the formula of each reactants or products when necessary, but you do not change the formula of the reactants or products. Let's look at one example. In such a simple chemical equation, you can simply add one or two numbers in front to try error the balance. However, I'm going to teach you a very systematic way, so let's try this way. Now first you draw a table. Okay, then you list down all the elements that are available in the equation. First you have H, look from left to right. Next you have Cl, you got calcium, and there's oxygen and hydrogen. So oxygen, hydrogen is already on top, so near right. Now this line represents before and after reaction. So on the left are before, and on the right of this line is after the reaction. Now we list down the number directly below the chemical formula. So there's one hydrogen, you put a 1 below, one chlorine here, a chloride here, calcium, one calcium, oxygen, 2 bracket OH means there are 2 oxygen, and 2 hydrogen. So you list out all the elements, the number of them directly below the chemical formula itself. One calcium, calcium is here, 1, 2 chlorine, 2 chloride, so there are 2 chlorine. There you are. H2, there are 2 hydrogen, and there's 1 oxygen. Okay, the purpose is for you to see that the number of hydrogens, let's say the first row, on the left hand side and right hand side are the same. So obviously it's not the same because you have 3 on the left hand side and 2 on the right hand side. So you have to try to balance it. So how do you balance? Now when balancing the equation, you always start to balance from the most complicated chemical formula. So for example, okay, let's try to balance from the calcium hydroxide here. Okay, there are 2 hydrogen and there are 2. Okay, calcium hydroxide, this is balanced. Okay, I don't do anything, so calcium is balanced. Once you put a tick, means that you cannot change the number on the whole column anymore. And for these 2, oxygen, there are 2 on the left hand side. Obviously all under calcium hydroxide cannot change anymore because you have already put a tick on this one. So you can change the last one. You can put 2 times the water, 2 times oxygen, so it's 2 times water. So this is balanced. Okay, oxygen is balanced. Now next, since you balance the calcium already, this chloride here cannot change. Okay, let's look at the other side. 2, I need 2 the other side, so it's times 2. I put 2 in front of the HCl. It's balanced. Then you check. Hydrogen, there are 2 plus 2, 4. 2 times 2, 4. So you realize that all elements are balanced. So a balanced chemical equation here is 2 HCl plus 1 calcium hydroxide become 1 calcium chloride and 2 H2O. This is a balanced chemical equation for this example. Example 2. In this reaction, CH4 reacts with oxygen to form CO2 and H2O. So I draw a table again. First element you see from the left to right, C. Second element, H, then O. The other side is all same already. You only have 3 elements in this equation. So you write the number of the carbon directly below CH4, so it's 1 carbon and 4 hydrogen. There are 2 oxygen, you write directly below. There's 1 carbon under carbon dioxide, and there's 2 oxygen, 2 hydrogen, and 1 oxygen. Now you compare both sides, 1 to 1. Okay, it's balanced already. So it's balanced. 4 to 2, so I need to times 2 here. So second one is balanced already. So you have balanced carbon and hydrogen. The next one. So since you already balanced this one with the carbon in front, this number 2 cannot change anymore, so it's fixed. And this one also is fixed already, because you actually balance the hydrogen on both sides, so you cannot change. So it looks like this number of oxygen is total of 4. Now this side, you must multiply, left hand side must multiply by 2. 2 times 2 gives you 4. Hence, it is a balanced equation. 1 CH4 plus 2 O2 give you 1 CO2 and 1 H2O. It's a balanced equation. Sorry, it's 2 H2O. Now next example. So I need to just draw the table. Okay, list down the element from left to right. C, H and O. There are 2 C's and 6 H under C2H6. Under O2, oxygen. Here has 1 C and 2 O and 2 H, 1 O. Now, you always start balancing from the most complicated formula and leave the simplest to the last, because you can multiply anything to the simplest formula in order to balance with the rest. So I try to leave this alone. I leave the oxygen alone. Let me try to balance the most complicated one, which is a C2H6. Now carbon, left hand side there are 2, right hand side there's 1, so I multiply by 2. So times 2 times 2. So it's balanced. Carbon is balanced. Now there's 6 hydrogen on the left hand side, so I must times 3. Everything must times 3 under the water. So I have 6 balanced with the 6 in front, balance. Now because you have already balanced the carbon for the CO2, so the oxygen below you cannot change anymore. You multiply any number at the bottom, the top will be, the carbon will be affected. Likewise for this, you already multiply 3 to the hydrogen, so this also times 3, and this number also cannot change. And these together they are 7. 2 times 2 plus 3 times 1 is 7. Now 7 is an odd number, and the oxygen comes in the form of a pair. So O2, no matter what number I multiply in front of the 2, you will get an even number. So how do you get odd number 7? You can now multiply by a fraction. The simplest way is to look at this one. Even number, you always multiply by something over this same number, which is 2. So if I want a 7 here, I simply multiply by 7 over 2. 7 over 2 times 2 will give you a 7. And numerically is balanced. 7 on the left hand side, 7 on the right hand side. So you actually have 7 over 2 oxygen. Now, if you count the number of atoms before reaction, after reaction, it has to be balanced, exactly balanced, because this table shows that left hand side, right hand side, they're all balanced. But can I leave this formula in terms of fraction? Actually, you can. But of course, we want to make it look nicer by making it into a whole number. How to make it the whole equation all into whole number? You multiply by the denominator 2. So we multiply by 2, you get 2C2H6 plus 7O2 times 2 give you 7, so it's 7O2 to give you, and here times 2 is 4CO2 plus 2 times 3, 6H2O. Now you check again. The number of hydrogen on both sides, 2 times 6, 12. 6 times 2 on water side is 12. Number of carbon, 2 times 2 carbon on the left hand side is 4. 4 times 1 on the right hand side is also 4, correct. Now left with oxygen. On the left hand side, 7 times 2 is 14. Right hand side, 4 times 2 is 8. 8 plus 6 times 1 is 14. So this is a balanced chemical equation.